This video is going to cover the point-slope form of a linear equation in two variables. So I actually want to start by just kind of briefly explaining where this formula is going to come from. So in previous videos we learned that slope is rise or change in y divided by run, change in x. That's the definition of slope. Let's see what happens if we multiply both sides by the run, by the change in x. On the right-hand side, we can cancel those runs out, one on top and one on the bottom. So now I'm left with run times slope equals the rise. Or if we write it in the opposite order, the rise has to equal the slope times the run. In terms of variables or letters, rise is our change in y, has to equal slope, which is m, times change in x. And that is our point-slope formula. Our point-slope formula says we can take y, which is our variable, minus a y value on the line, and that has to equal the slope times our x variable minus an x value on the line. So again, m is the slope. We'll plug that into the formula. And the x1, y1 can actually be any point on the line. The plane x, plane y, those are our variables. They'll stay x and y. So let's see how this works with a specific example. Find the equation of a line with a slope of 2/3 that passes through the point -3, 1. So let's see how this works with that point-slope formula. In this problem, they're giving us the slope. So we're going to go ahead and plug 2/3 in for m. So I've got my formula. I replace the m with 2/3. The y and the x stay a y and an x. And then the x1, y1, that is my point. So I'm going to say x1 is -3, and I'll plug that into the formula. And y1 is 1, and I'll plug that into my formula. So now I have y minus 1 equals 2/3 times x minus -3. Minus a negative turns into a plus, and so y minus 1 equals 2/3 x plus 3 is my equation in that point-slope form. So I've taken the information and I've written an equation in point-slope form. Sometimes that formula will be appropriate, but frequently you might be asked to take this equation and solve it for y. That's the same thing as putting it in that slope-intercept form, which we learned about in the previous video. So let's see what that looks like. So if I want to solve this equation for y, if I want to put this in slope-intercept form, I have to take the 2/3 and I'm going to distribute it to the x and to the 3. So I'm going to get rid of parentheses first. So I've got 2/3 x, and then 2/3 times 3, that's 2/3 times 3 over 1. If I multiply straight across, I get 6 over 3, which reduces to 2. So 2/3 times 3 is 2. And then finally, I'm going to add 1 to both sides. And now I have y equals 2/3 x plus 3. This is my equation in slope-intercept form. So I was able to take my point-slope form and simplify it down to slope-intercept form. I can see that the slope is 2/3, and I also know that the y-intercept has to be located at 3. All right, we're going to do several more examples of using this point-slope form. Let's see if we can find the equation of a line that passes through the points 2, 5, and -1, 4. So anytime a problem, just in general, asks me to write the equation of a line, I typically go to this point-slope form. Y minus y1 equals m times x minus x1. So that's my preferred strategy anytime a problem says write the equation of a line. That means I'm going to have to compute the slope. I'm going to have to plug something in for m, and I'm going to have to plug something in for x1, y1. In this problem, they gave us 2 points. So we definitely know an x1, y1, but they didn't give us the slope. And so we're going to actually have to compute the slope. I'm going to say the first point they gave me is my x1, y1, and the second point is my x2, y2. My slope formula says we take change in y divided by change in x. So I'm going to take y2, which is 4, minus 5, over negative 1 minus 2. That becomes negative 1 over negative 3, or positive 1/3. So the slope of this line is 1/3. Plugging that into my formula, my slope is 1/3. And then it actually turns out we can use either point for our x1, y1. It actually doesn't matter. We'll get the same answer in the end. I'm going to go ahead and just use the 2, 5 as my x1, y1. So I'm going to put 2 in for x1, and I'll put 5 in for y1. And there's my equation in point-slope form. Y minus 5 equals 1/3 times x minus 2. Let's actually simplify this and put it in slope-intercept form. So I'm going to take the 1/3 and distribute it to the x minus 2. So now I have y minus 5 equals 1/3 x, and then 1/3 times 2 over 1 is 2/3. So y minus 5 equals 1/3 x plus 2/3. Then to get y by itself, I'm going to add 5 to both sides. So negative 2/3 plus 5 over 1. We need a common denominator to do the addition. So I'm going to take the 5 over 1 times 3 over 3. 3 is my common denominator. So now I have negative 2/3 plus 15/3. And if I add the numerators, negative 2 plus 15 is 13, and I get 13/3. So my final answer in slope-intercept form is y equals 1/3 x plus 13/3. Before we move on, I want to define two different types of lines, or two different vocabulary words. We say that two lines are parallel if they never intersect, if they run at the exact same angle, or if they have the exact same slope. Parallel lines always have the same slope. Two lines are said to be perpendicular if they intersect and make a 90-degree angle or a right angle. So perpendicular lines always make a 90-degree angle. The slopes of perpendicular lines are related as well. In fact, those slopes are what we call negative reciprocals. What that means, in symbolic form, is the slope of one line is equal to negative 1 divided by the slope of the other line. This is a little bit easier to understand with numbers than with letters. So for example, if the slope of our first line is 2, that's the same as 2 over 1. So we can take that slope and we flip it. It becomes 1 over 2. That's the reciprocal part. And then we make it negative. We change the sign. So 2 over 1 and negative 1 over 2 are negative reciprocals. That could be slopes of two perpendicular lines. Or here's another example. If one line has a slope of negative 4/5, the other line would have a slope of 5/4. Notice that I changed the sign and I flipped the fraction. So that's what we mean by negative reciprocals, and perpendicular lines always have slopes that are negative reciprocals. So let's determine if the lines given are parallel, perpendicular, or neither. And so the way to answer that question is to compare their slopes. We've got the line 2x plus y equals 5 and y equals negative 2x minus 1. So 2x plus y equals 5. I'm going to put this in slope-intercept form, and I can do that by just minusing the 2x. solving for y. So that turns into y equals negative 2x plus 5. Now that my equation is in slope-intercept form, I know that the slope is the number in front of the x, so negative 2. The first line has a slope of negative 2. The second line given, y equals negative 2x minus 1, is already in slope-intercept form. It's already solved for y. So I know what the slope is. It's the number in front of the x. It's negative 2. Since both of these lines have the exact same slope, they must be parallel. So these are two parallel lines. Here's another example. We have the lines 3x minus 2y equals 6 and 2x minus 3y equals 12. So if I want to determine if these lines are parallel, perpendicular, or neither, my first step is to find the slope of each. To find the slope, I'm going to put the lines in slope-intercept form. I'm going to solve for y. So for the first line, I have to minus the 3x. That gives me negative 2y equals negative 3x plus 6. And then I'm going to go through and divide everything by negative 2. So now I've got y equals negative 3 over negative 2 is positive 3 over 2. So positive 3 over 2x. 6 over negative 2 is negative 3. So the first line given has a slope of 3/2. That's the number in front of the x. We'll go through the same process with the second line. 2x minus 3y equals 12. I'm going to solve for y, so I have to minus the 2x from both sides. That gives me negative 3y equals negative 2x plus 12. Finally, I'm going to divide every single term by negative 3 to get y equals, and again, we've got a negative divided by a negative, so negative 2 over negative 3 is positive 2/3. So y equals positive 2/3 x. 12 divided by negative 3 is negative 4. So the second line given has a slope of 2/3. These slopes are definitely not the same, so not parallel. And I notice that the slopes are reciprocals, they're flipped. I have a 3 over 2 and a 2 over 3, but they're not negative reciprocals. They don't have opposite signs. And so that means they are not perpendicular either. This is an example of two lines that are neither parallel nor perpendicular. Now I would like to note if one of these slopes was negative, then it definitely would be perpendicular. They would be negative reciprocals. All right, let's go back to that point slope form that was introduced at the beginning of this video. Let's see if we can find the equation of a line parallel to 2x plus 3y equals 5 that passes through the point 2, negative 1. So find the equation of a line. As soon as I see that, I immediately jot down that point slope formula. Y minus y1 equals m, x minus x1. So I'm going to have to determine the slope and a point. Anytime I want to write the equation of a line, I think about that point slope formula, and I always need to plug in the slope and a point. In this problem, a point was given to us, 2, negative 1, but we have to do some work to find the slope. We're going to get the slope from the fact that our line is parallel to 2x plus 3y equals 5. So I'm going to try to find the slope of 2x plus 3y equals 5, and I'm going to do that by putting it in slope-intercept form. So I'll start by minusing the 2x. 3y equals negative 2x plus 5. Then I'll divide everything by 3. So now I've got y equals negative 2 over 3x plus 5 over 3. And the important piece of information is that slope is negative 2/3. Because the line I'm interested in is parallel, it has to have the same slope. So I'm going to take the negative 2/3 and I'm just going to plug that in for m in my formula. Then the x1, y1, that's the point that was given to us. x1 is 2, y1 would be negative 1. So I've got y minus negative 1 equals negative 2/3 x minus 2. minus a minus becomes a plus. So y plus 1 is negative 2/3 x minus 2. I'm going to go ahead and distribute the negative 2/3. So negative 2/3 times x. And then I have to take negative 2/3 times negative 2. It's a negative times a negative, so it's going to be a positive. And then I'm taking 2/3 times 2/1. If I multiply straight across, that gives me 4/3. So y plus 1 equals negative 2/3 x plus 4/3. Finally, solving for y, I'm going to subtract 1 from both sides. 4/3 minus 1/1. I need a common denominator, so that becomes 4/3 minus 3/3, or 1/3. All right, so final answer, y equals negative 2/3 x plus 1/3. Here's another one. Find the equation of a line perpendicular to y equals 1/3 x plus 2 that passes through the point 210. So this is kind of similar to the problem we've just done. We want to find the equation of a line, so I'm going to use that point-slope form. That means I need to know the slope, and I need to know a point. The point is given to me, that's the 210. To get the slope, I'm going to use the fact that our line is perpendicular to y equals 1/3 x plus 2. The slope of the line given is 1/3. So a perpendicular line would have a slope that is its negative reciprocal. I'm going to take the 1/3 and I'm going to flip it. That gives me 3/1. And then I'm going to make it negative. Negative 3/1 is the same thing as negative 3. And that's the slope we're going to use in our formula. So I'm going to take negative 3, plug that in for m. And then the 2 gets plugged in for x1. The 10 gets plugged in for y1. Finally, we can put this into slope-intercept form by distributing the negative 3. So y minus 10 equals negative 3 times x plus 6. That was negative 3 times negative 2. Finally, I have to add 10 to both sides, and that gives me my final answer, y equals negative 3x plus 16. So in general, we can use this point-slope formula to get the equation of a line, and it means we just have to know a point, and it can be any point at all on the line, and we do have to somehow figure out the slope. Now I want to show you one special case where we actually don't have to do this formula to get an equation. And let's just take a look at this example and then I'll explain what I mean by special case. Let's write the equation of a line that is perpendicular to y equals 2 and passes through the point 1, 5. Well, y equals 2 is a horizontal line. There's no x in the equation. That means the slope is 0. The slope of a line perpendicular to 0 would have a slope that's 1/0 or undefined. So this is the one case where we can't actually find the slope of our perpendicular line. Instead, I'm just going to think about this problem and draw a picture. Y equals 2 is a horizontal line. The y values are always 2. It has a slope of 0. It's a flat horizontal line. A line that's perpendicular to a horizontal line would have to be vertical. So we're trying to find a vertical line that passes through the point 1, 5. This problem is really just a fancy way of asking us, what is the equation of a vertical line that goes through the point 1, 5? Vertical lines are always of the form x equal a number. Horizontal lines are y equal a number. So if our vertical line goes through the point 1, 5, the x value has to be 1. And that's our equation, x equal 1. So the horizontal and the vertical lines are really kind of the one special case where you don't have to use that point slope form. And in the case of vertical lines, you can't really use the point slope form because vertical lines have undefined slopes. But in all other cases, that point slope form will get you the equation of a line. You just have to know the slope and any point on that line. All right, that was my last example. I know there's a lot of information in this video, so please reach out if anything is unclear.